So we'll look at hash indexing today, and two categories of indexing is available using hash functions. One is static hashing and one is dynamic hashing. So let's look at static hashing. Rusty, do they give the projects to you, and is it before the lecture? When is the deadline for them?
I actually thought they were going to hand them in to you in lecture.
Okay.
Fine. There are some in the box already.
Great.
So.
Okay, that's fine. So right after the lecture, we can go in. If anybody hasn't put in the box, give it to me, or we can make copies and then make the grid and distribute to other people to evaluate the projects. Okay, so we are talking about static hashing. So hashing would be a hash function that goes on so you have a key value and you feed into a hash function, and then this maps to multiple groupings you can think of, which they call as buckets. Okay, so you'll have set of buckets which follow the rule defined by the hash function, and that is how the classification occurs. So when you want to do a search on a key, you put in the value, apply the hash function, and then you know which bucket it will fall in. So searching is really quick in hash functions, and they are very highly optimized for search functions. The problem is that if you, so it can contain, say, 4 data fields, and all these 4 are filled up. Then we have a similar situation as ISAM, remember, index sequential access method, because this is static. When you define this, you define the number of buckets, you define your hash function, so you will have to start adding now overflow pages. And that is where performance degrades, because you'll have to then start searching into more pages. As once you identify the bucket, then you have to go in and keep on reading more pages into the disk. The way to handle is, one is the way, remember, to keep it 80% occupied to start with, so you have enough space so you can add more. But once it is into the overflow pages, either you do a rehashing, in that you read everything, redefine the number of buckets, and you start from scratch. That is again a very expensive operation, and while you are doing it, the data is unavailable because there is no indexing file. So these are the things that happen with the static hashing. So how do you overcome the problems of static hashing? The second is dynamic hashing. I'm going to draw the diagram from the book. It is in dynamic hashing, you have so you have extensible hashing and linear hashing. So in extensible hashing, what you do is, now I'll expand extensible hashing, then we'll get to linear hashing. In extensible hashing, you maintain a directory. And this is a directory of pointers that will point to buckets. So let me actually write the whole example. Now, how many feet? 4 to start with. I think that's what they do. 4. Okay. And do this. So this is 0, 0. I'll just explain the hash function also that they're using. 1, 0, 1, 1. And this has 4, 12, 32, 16, 1, 5, 21, 13, 10, 15, 7, 19. So what is being done is, let me write this also, 0, 1, 2, 3, 4, 5. This is 1, 2, 4, 8, 16, 32. So this is n, and this is 2 to the power n. Okay, so if we have 4, now 4 gets the representation 0, 1, 1, 0, 0. Okay, 1, 0, 0, and the last 2 digits are 0, 0. So this, it maps here. Okay, same would happen if it was 12. 12 would be 1, 1, 0, 0. So last 2 digits are 0, 0, so it maps here. Okay, same for the rest. Say if we take 15, 15 would be 12, 1, 1, 1, 1. These 4, and so 15 is going to map here. Now what we are doing is we are adding as we are referencing as with this hash function and taking the last 2 digits and mapping them. Now if we add another number here, okay, that is where we have to take care of things dynamically. I'll keep this here, because in static we would start extending this with a pointer because we don't have a choice, but now we will dynamically rearrange this. And what number do they add? Do you know what number they add? I just want to take, which one? 20?
20 from that.
Okay, so let us represent 20. 20 would be 16 and 4, so it would be 1, 0, 1, 0, 0. Okay, so that means 20 should go here, but it can't contain more than 4. So we are going to split this, and we are going to split this one into, so I'm going to just rewrite this part again. Okay, this only that row, and when this splits, we are going to have 4, and I'll tell you why. 4, 12, 20, and the other one will have 32 and 16. What suddenly happened is now you need to distinguish between these two. Okay, so the way to do it is that you will double the directory. You only added one extra row for this to accommodate this 5th one, but you will double this directory. Now doubling this directory means right now there are 4 members in this array of directory. We are going to make it 8 by adding is that 8? Okay. What we will do is we will say 0, 10, sorry, 0, 0, 1, 0 1 0 0 1 1, then will be 1 0 0 1 0 1 1 1 0 1 1 1. Okay, so now our directory will become this, and we will start looking at three representations of same numbers up to 3 digits.
You have to recast the whole table?
No, you'll recast the, okay, recasting, yes. I mean to say, you'll have to now repoint the pointers, if that is what you meant. You're right. Okay? So I'm going to erase this part and map this new one to it.
What's in the box before 16 on your first new
Oh, 32.
32?
Yeah. Okay. So let's see what will point where. This one goes away. So now we have 5, and 1 would be, if we say 1, that would be 0 0 1 0. Okay, so 1 will point to this bucket.
No, it's the O1.
Is it? Which one did I do?
Yeah, it's the one above it. It's 001.
Oh, sorry. So I did wrong here. Yeah,
Yeah.
I'm sorry. Thank you.
And you know that all the rest of the...
No, all of them are going to, so let's go to 5. Okay? Okay, let's go to 5. 5 will be this, right? 110? Is that correct?
101.
Oh god. 101, sorry. So 5 is going to be, wait.
So what they've done is they haven't actually split any of the buckets other than bucket A. So they've
Yeah,
got
bucket A-
A2, but B, C, and D are pointed to by both.
They're going to be both.
Yeah.
Yeah, exactly. So where is that? 101. So this goes here.
So until it gets full, you don't bother splitting it.
Exactly. So what you end up doing is you save, that is the gist of the whole thing. You split only when it is needed, but directory you can change because it has very less overhead. Okay, this could have up to 100 data pointers here. Okay, so you don't end up duplicating this. Remember, in our static hashing, we would end up adding another one as big as that. Okay, and reducing the performance. Here, as it is needed, you'll keep on duplicating. So I'll just, do you want me to complete the whole table? Or, I think this is, or I'll just map it with this. Yeah. Okay, these two. So let's go to 16. 16 should be this, so, right? So all zeros. And same should be 32 then? Yeah, okay. Next is 4. 4 would be 100. So 100 will get here. Okay?
And where did the 32 come from again?
Oh, it was already there. It was in our first 4.
It was?
Yeah. Wasn't it there? I thought it was.
Yeah,
it
I
was there.
copied down.
Okay.
So if you have like a million records, you have to do a lot of work.
But it really improves the performance, because if you could have a million rows like this, you just looking at by this directory structure, you know where at least to, so 1/1,000,000th of a record you have to search. Okay. So this is extensible hashing where you do directory doubling. Okay. Now let's look at, has anybody installed like Unix OS and Oracle on it, or any database on Unix?
Unix.
Solaris, I meant Solaris.
Uh,
Not
we-
Unix.
We all did.
Well,
Oh, you're on?
Linux,
Oh, yeah,
not on Solaris.
Yeah.
No, I was saying it is a little different, and when I did it, I learned a lot because Linux is very straightforward, and
That was straightforward.
oh, okay.
It took us days.
Really?
The installation
Oracle
was
install.
yeah. The installation instructions were not terribly clear, and
You use the one on AD's site, right?
Yeah, we also have slower. I mean, we have slow, small machines, which was probably the bigger problem. But yeah.
No, because you must be having the same Celeron 500 with 128 meg RAM at least. That should do it.
At a
That
minimum,
takes
it
like
took
2
a
hours.
day.
2 hours.
Oh,
Oh, longer?
It took 4 to 5 hours to create the initial
Database.
databases and indexes.
Oh. Okay. That's strange.
Or do we have poorly tuned machines or something?
it was a bit of an ordeal.
That's if you were lucky. If it worked the first time.
Okay.
Yeah.
Postgres was pretty quick to me.
It's one file. Okay. So linear hashing is the other technique. In linear hashing, Alex, I'm going to use the yellow chalk. Oh, okay. In linear hashing, let us think of these as records. In linear hashing, you maintain a pointers. The idea here is you'll have a group of HN. Then another variable is called level, or you can say, what is it called? Round 0 to n, or whatever round number is, and then you have the buckets. And you have a variable called next.
It's round a function.
Round is the round that you are taking, no variable. You can think of it as the round. That if you are taking the first round around it, second round, third round, that way. So to begin with, you have round 0, and next is also 0. The variable next has value 0. I'll fill up the table the way it is in the example so I can tell you how things are working. I will just write this up here. H0, and in this there are 0, 0, 0, 1. So they take 4. 1, 2, 3, 4. So we can extend this later on, but let's take 4. 0, 0, 0, 1. 1, 0, 1, 1. Okay, so you have the round 0 or level 0. And what is the data that is in here? 32. 44. 36. 9. 25. 5. 14. 18. 10. 30. 31. 5, 7. 11. Okay, their hashing function is that they take the mod. So you have right now 4. I just want to make sure that is their hashing function. Just let's make sure 44 mod 4 would be equal to 0, right? Okay, so this is their whatever is the remainder is they are mapping here. Is that correct? So 9 mod, yeah, okay. So they take this value, find the modulo, and then whatever is the remainder is being mapped here in these. Okay, so if we took 9 mod 4 would be equal to 1 because 4 times 2 is 8, and this will be mapped as 0, 1.
It's possible they're just using the same hashing that they were using before, the last 2 digits in the binary number, which corresponds to mod 4.
No, it is not the same, because if you think, if you have 9, 9 would be, let me think, it matches, but is that the same? Can you make sure of that? I don't think it was the same hashing function, because in extensible hashing you take actually the number and convert that. So 5 is 101. Yeah, no, it is not the same, because if you take in extensible hashing, 5 will map to 101. Okay, but in this 5 will map to what? Only 1. Let me just make sure. Just 1 second.
It seems like
I just want to
H0, so the level, the first level that they do it on, they're only looking at the last 2 digits. And then the next level of splitting, H1, they're looking at the last 3 digits.
Exactly. So then 5 gets mapped to, see where? It doesn't get mapped to 00, it doesn't get mapped to 101. It gets mapped to 001. Right?
Right.
So they have different functions.
Okay.
Okay, so let me just clarify the point he raised. In the previous one, what we were doing were, whatever the number we were looking at, the representation was being used to map. Here, the hashing function actually takes the modulus of that, and modulo is the number of buckets here. Okay, this number n here. If there were 8 buckets, it would be different. Slightly different hashing function. I think that 5 made it clear. I wanted to make sure. Okay, so let us continue with this, with 4. Now if we want to add something here, let me see what they add here. Do they add 43? Okay, so what is the first one they add? 43, is it? Yeah, okay. So 43 goes into 011, or this 11 bucket. Because 43 mod 4 is equal to 3, and 3 will come here, 11. Okay, now suddenly what is happening is we have an overflow. This will trigger, now next was at 0. This overflow will trigger the split of this row. It won't trigger the split of this row.
Right.
Remember this. There is this difference. What it will trigger is, it will trigger the split of this row. And what you'll end up getting is, so once you'll trigger, that means you're going to double this directory. So it will become 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it will become Z.
What's the general mapping? Does any overflow signal splitting of the top row?
Exactly. Yeah, that is what is the whole concept behind this is, whenever you will have an overflow, it will trigger the split of the row that is pointing at next. Exactly. So after we will split this one, we will have a corresponding row for this, which will have a part of this data, but then next will point to here.
You increment next when each time you add some data?
Each
Or
time you split something.
Each time you split something.
If we were adding a number here, say whatever, some number x here, it won't trigger a split. You can, okay, I'll give you a little more information. In linear hashing, you can give a conditional split also. You can say split when occupancy goes above 80%. In that case, this will also trigger the split. But the reference, that example that book is using is whenever, so that it is easier to compare the two, is whenever there is an overflow, trigger the split. Okay, so this triggered the split. It is going to take some part of the data here, depending on how these three get represented, up to three digits now. You know, this is going to be re-evaluated with the 3 digits, and then the next will start pointing here.
Tell me again, I'm lost a bit. Like, what's the
Okay.
next pointer? What is that?
Okay, next pointer is, to start with, next is at 0. And it is pointing at the first bucket here. We added a new number 43 here, key value. Now there is an overflow in this row, so this will trigger the split of this row. And next pointer will move to here. So this row is already split, and the corresponding split is here at n. This is 0, this is n minus 1, right? If there are 4 rows, 0 bucket, first bucket, second bucket, third bucket, fourth bucket is here. So 0 will correspond to n. This would be the pair of the split. Then once this one will split, it is going to have its pair here.
I don't understand why the 0 bucket splits when there's still an empty cell.
Yeah, that is the fundamental premise of linear hashing. That you make it consistently, you keep on increasing. So the advantage remains that it is very uniformly distributed, the data, but you still have at the most 1 or 2 levels of overflows, because this is going to get split also after 4. So you're not leaving it also like in static hashing. So you are doing both the things. One is, you, with the previous example in extensible hashing, whenever you have to split, you have to do directory doubling, right? In this, even if you split this, you won't have to do directory doubling, because we have already done a directory doubling once, and till all of them get split, you don't need to do it.
Wait, so at this, when we just filled up the bottom row, or some row, so we split the top. Did we, or did we not double the index?
First time, yes, we did.
Okay.
Now, if we have to split this one, this first doubling itself will take care of it, right? Because
we can add.
exactly,
overflow.
yeah.
There also is no index here. I mean,
Yeah, there is no directory.
The thing
Yeah.
on the doesn't exist. The thing on the left there.
Okay.
So it's
The order in which they're split keeps them in the right order. Going down, we're not jumping around randomly.
okay. That is a very important point. I should have pointed out very clearly. Okay. This is a mapping that I'm showing it to you, that this is how it is being split.
So where's the new value 43 in that?
Okay, so the new value 43 will stay here till this gets split. Because now as values get added, they are going to rows, the next will always split. Even if I think, let me take you through an example.
When
I
you
think,
split that first row, you just open up a new blank row?
yeah.
The values in the first row don't move to the...
No, they do. Because now they will have to be reclassified if, do they distinguish when the third digit is counted in. With the second, they may still be same, but with the third digit, they may not be.
Wait, I don't get the 43 stays there, stays where?
here in an extra overflow.
Oh, it gets an overflow.
Yeah, yeah.
Thanks.
I'll take
How long does it stay there?
till it hits and gets this one gets split.
Until that one gets split. Okay.
Yeah, till the next pointer comes here and split is triggered. Okay. Let's run through an example because it'll just make it clearer. Okay.
Did that constitute round 2, by the way? Did the round pointer, or the round variable, did we increment that as soon as we split, or?
No, the round pointer will increase once we have finished, because now the round has to. Yes, whenever you split.
Just when you split, not
Yeah.
when you
When you add a new, yeah.
when you double. The
When you double the reference index. Okay.
But if you've got like a lot of data going into just one field, specifically, it's better to have 1 or 2 overflow pages.
So it's arbitrary to think start with your next and in the first row, right? You could start with your next pointer anywhere.
Can you say it again?
You could start with your next pointer.
First time it is initialized to 0.
Yeah, but that's an arbitrary selection, right?
No. It'll, because you have to go in this. You always follow this when you define this file. You define the number of buckets in it, right? You define your n value.
Yeah.
The next pointer will be pointing to the 0 value. It is always initialized there till you start adding data to it. So you have this file, right? It will be initialized. Next will always be initialized to 0 once you start working. But once you've started working with this file, it will start traversing.
No, yeah, but why is that not arbitrary?
Why should it be arbitrary? Because
suppose I start my next pointer with 1.
next pointer went 1, okay?
In the second, yeah.
Okay.
If you're there,
That's how I
then,
started.
then you've already copied one down. So there's a 5th row.
No, he's saying, no, his question is, he says, why should you start here? Remember, we start always from 0.
Right.
I'll tell you why. Because how do you know then you have split all the rows before it?
I don't know, I guess I'll have a mark or something.
So you end up introducing more markers, right? You'll have to know how many rows have been split before this, right? Okay, I'll ask you one question.
Okay, I see you. Okay. Fine.
Because we need to know. I'll ask you one thing is, if you are here, okay, and I find a number that maps to bucket 0. How do I know whether this bucket is split? Should I look only here or its corresponding row down here also?
Yeah, no, I see you save some information by starting there. I agree.
Not just information, you have to realize one more thing is, once I hit here, I know this row is before the next pointer. Okay? If this row is before the next pointer, then this has been split. So I should actually go down and search for that value in both of these. Try to think in the form of searching also. If we started here, you understand what I'm saying?
I agree, you get
If we started here, then we would have no way to actually knowing whether we should go, there is a corresponding row below this or not. Okay?
So I guess actually my next question is actually exactly this thing about searching. Like, what's the most efficient way to search then? I get you were just about to say that? Or?
It is, if you're doing just searching, hash tables are the best.
No, I see that. But now it's a bit, you have to be a bit more careful at least here because your buckets might be split and stuff.
You don't have to be careful at all, because you would know. Because you know, if my pointer is at 1, every row before it is split. This hash function, say pointer is at this value, okay? If this hash function mapped me to a bucket in which the value is less than the pointer, then that row has certainly been split.
No, so my question is then, you can now go in and the value you're looking for can be in several different rows. How do you know exactly what rows you're going to?
Yeah, so you will pull out both of these. You know the corresponding row that is split for this. The 0 corresponds to n. So you will pull out these two rows and your number will be either of in these two.
No, but suppose now it's not 2 rows, suppose it's 500 rows.
But you'll always have only 2. Because once you are split, your number of n will increase. That is all it will happen.
You never have to look in more than 2 buckets.
Exactly.
Well, except that row could split. I mean, if
No,
you keep
this.
going.
No, you won't go in here because now your n will increase. Once you have split here,
What's n?
n is the number of rows you start with.
Okay, great.
But it's so the split
So now
rows-
that is when you'll go into level 2. That's
Right.
once we hit here, we go into level 2, and then the number of rows is 8. Okay, now if this thing splits,
You had another one.
then we have the corresponding one, number 9 here.
Doesn't that give you three rows then?
No, these. Why are you saying it will give you 3 rows? Because these two now are being distinguishable on the basis of the third.
Oh, the third.
So now the 4th digit is going to come in. Exactly. We are just going back up. So you'll always end up looking, you won't look at 500 rows that become child, 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 because once you split once more, they become distinguishable.
Okay, so suppose now I have a number, I want to find out where it is. Do I search from the right or the left? I'm just trying to,
In what sense?
one row. Yeah, suppose.
If you're keeping these
No.
sorted.
No, forget about those. I mean, like, if I have to find now a number using my hash function.
Yeah.
Do I start with the hash function number 2 or hash function number 0? I'm just trying to.
You know what the
But you
round
have-
is. You look at the round pointer, right? And that will tell you which hash function,
How does that tell me?
isn't it? Because the round pointer will say whether we're still in a 4-row index or 8-row or 16.
So you took the first round. Okay, first round, your number of rows is 4. In second round, your number of rows is going to be 8.
All right, so. Okay, so your hash function is kind of replacing one another.
Exactly, because your number of rows is increasing, right? And your number of digits that you are mapping is also increasing.
H1 is just mod 8, and H2 is mod 16.
Yeah. Is that okay?
Yeah.
Try to look at that example once more. Do you want me to do it again? Or if it is clear, then I don't know.
Just the buckets are increasing.
Yeah, exactly. Yeah. And you keep track of how many. The reason why you want to keep track of next is you want to know whether your mapping is in a row before it, so you know you have to look for the corresponding one here.
Like an intermediate case.
Rusty, you are doing the recitation today? Mike? Okay, I'll just ask him to do this example once more in the recitation. Just go through this example once more in the book. That is about all about the hash functions and indexing. Just look at these examples. These are very well explained in the text, and it'll become very clear.